when you have more than one variable. Alright, so a polynomial in two variables, x and y, contains the sum of one or more monomials of the form a, which is a constant, x to the n, y to the m, so just, like 3x squared, y to the fourth, whatever, right? Constant a is the coefficient, exponents m and m, whole numbers, right? Only whole numbers with polynomials for the exponents. The degree of it is the highest one that adds n and m together, so that adds those exponents together. We briefly covered that before, and so the degree is the highest of all of those. And then we don't even need to look at that because simplifying these is just intuitive, right? So the only thing, like terms, the thing we need to get about like terms through our head, if you haven't done so already, is basically like terms are just things with the same variable, or in this case variables, attached. Alright, so we have x cubed minus x cubed, which is just going to cancel, right? We have minus 4x squared y. So I'm looking at this, the x squared y. Do I see any others? Here's an x squared y. So we have negative 4 of this thing minus a negative, so adding 6 of that same thing. So altogether we're going to have 2 of that thing, which is x squared y. Alright, so those are done. 5xy squared. Is there any xy squareds? There is no other one, so I'm just going to leave it as 5xy squared. That one's done. Minus y cubed. Minus another y cubed is going to be minus, if you have minus one of these things and minus another one of those things, I'm going to get minus 2y cubed. And when writing, when you have polynomials and multiple variables, there's no real standard equation, right? Like before we did descending order, but now that we have multiple variables, there isn't really descending order. Like these all have degree 3, right? Because 2, 1, 1, 2, and 3, those are all degree 3. So there's really no descending order. I just do what looks nicest, and usually what I like to do is if it has X's or if it has A's or whatever, I like to put the thing that's first in the alphabet first, right? And then do descending order like that. So this is already kind of has it, right? X is before Y, so I want to do the X first, squared, X squared is first, and then I have the X, and then there's no X's here, and then that's how I would go. And then if you can, maybe ascending order for the other variables, so this is Y squared, y cubed, the other way. That just looks nice. And that's all that one is. Okay, this one, again, if it's a plus or a minus in here, squared, you can't just throw it in there like that. That's the biggest algebra no-no in the entire world. Squared means something times itself, 4x to the fourth plus y squared. So 4x to the fourth times 4x to the fourth is 4 times 4 is 16x, and then x to the fourth times x to the fourth, add the exponents x to the eighth. We need to be comfortable with those exponent rules. And then 4x to the fourth times y squared. Don't freak out. That's just going to be 4 times x to the fourth times y squared. All right, now this one, y squared times 4x to the fourth. That's going to be plus 4x to the fourth y squared. And then y squared times y squared is going to be y to the fourth. And then we have some like terms, 16x to the eighth plus, and then we have 4x to the fourth y squared, and then another 4x to the fourth y squared. So together that's 8x to the fourth y squared plus y to the fourth. And if you ever get confused by like terms, I like to think that my super non-mathy way of saying it helps. Of saying, okay, you have 4 of this something, then you have another 4 of this something. How many do you have altogether? 8. of that something, right? You could basically like replace x to the fourth y squared with apples, right? So if you have 4 apples, right, x to the 8th isn't apples, x to the 3rd, y to the 3rd isn't apples, only x to the 4th y squared is apples. Oh, and here you have 4 more apples. You can add them for 8 apples.